Hiya guys, it's Terry from Smoo's Workshop here, coming at you with part 3 in my electrickery series. In this section we're going to be talking about a couple of things. They're all kind of similar, and this is more orientated towards lighting up your kit, obviously. We're going to be talking about diodes, and we're going to be talking about LEDs, which are light emitting diodes. We're not going to go into laser diodes that you would find in your DVD players and things like that. We're going to be talking about stuff that you can use in your kit to light your kit up, and you know, as I mentioned in a previous one, common things like headlights, indicators and things like that. So where do we start? Right, so I suppose I have to tell you what a diode is. Now, I've got some stuff on here to show you later on, but just going to move those off to the side for a second. And as I mentioned in my previous one, I hope it's not like a school lesson for you guys, but I do have to do a little bit of theory. Yeah, theory, yeah. Well, so, right. What we're going to be looking at, right, big piece of white paper, we are going to be looking at diodes. Right, what is a diode and what does it do? Now, its symbol on a circuit is pretty straightforward. Remember before we were drawing circuits where we had the battery plus and the minus and the cell and all that sort of thing in there. Right, a diode is symbolised like this. So what does a diode do? It allows current to flow one way, but it does not allow the electricity to flow the other way. What are the uses in that? Well, for example, say you've got an IC chip, and we get on to the more complicated stuff. You've got an IC chip with however many pins, say 16 pins, like in a decade chip when we're doing the fancy flash and stuff, right? So you've got a wee IC chip. And you're going to have, right, so this pin's connected to positive, just for example, and this pin's connected to negative, right? We're going to feed a signal in there to tell it when to switch on to the next thing, right? And all of these pins are going to go to LEDs. Now, an LED is a diode symbol with two lines coming off it, a couple of wavy lines. So say we've got quite a few LEDs coming off this IC chip, right? But in some instances, we might have one pin, right, driving more than one LED. Or actually, let's make it, there's two pins driving these two LEDs. The problem we have is these IC chips usually run at, yeah, some of them run at 5 volts, but anyway, say we've got power coming up to this LED, right, when the IC chip sends a signal, and then when this pin sends a signal up, it's also going up to this LED, but the thing is, both these LEDs are connected, right, on these two pins, but they're shared. So how do we stop the power coming up for one LED, going back to the chip and damaging it? We put diodes in line, which allows power to go one way, but not the other way. Is that, have I explained that well enough? It's going to be later on, but basically, diodes allow the flow of current one way, but not the other. But they're not perfect. Your standard sort of what we call silicon rectifier diodes will block, depending on the spec of the diode, quite a lot of what we call reverse voltage. Okay, so a standard silicon diode will block quite a lot of reverse voltage. So we'll call these forward biased. I'm trying not to confuse you. So these are forward biased. So they promote the flow of electricity that way, and once it gets up to a silly amount of voltage, it will eventually flow back the way. But they're generally used in, I touched on it briefly when we were talking about what electricity is, and they're used in AC circuits predominantly to rectify voltage, but we're not going into that because we don't need that to light up stuff in your kit, but we might need standard diodes. So let's show you what a standard diode looks like. As I say, for the standard stuff where you're just wanting to light up a single LED, you won't need diodes apart from the LEDs, which are light emitting diodes. So I'll bring this back in. So I have two diodes here. They are, this one is a 1N4001. It takes up to, I think it's 30 amps. The diode itself has a line on one end. That's the negative side. So you always want to have the line on the end of the diode towards the negative. So power comes in for this end, can flow through it and come back out this one, but it's not allowed to go back the other way. Okay, so that's an IN4001. In the experiments we're going to be doing, we're probably going to use, I say IN, 1N. We're going to use 1N4007s. This is a standard 1 amp diode, and it allows the current to go through that way, not that way, and it can handle up to 1 amp of power. Okay, and that is what you call a standard silicon rectifier diode. Now, as with all the silicon-based stuff, because silicon is a semiconductor, these do cause a little voltage drop. So if you put one of these in the circuit, it needs a minimum of 0.6 volts before current can pass through it. So if you've got a 6-volt battery and you're driving something, you've got to remember this is going to take 0.6 volts off of it, so you're only going to end up with 5.4. And it's something to remember when you're doing your mathematical stuff later on with resistors and stuff. But if you've got a diode in the circuit, it does take a minimum voltage and creates a voltage drop of 0.6 volts. Another thing they're used for is reverse polarity protection. As we looked at on the breadboards, you can pretty much put your plus and minus wherever you want. But then you put a chip on and you accidentally connect the wires the wrong way round. A diode will stop you damaging anything. It allows the power to go through the right way, but if you connect it up the wrong way, it doesn't allow current to flow. So they can be used for polarity protection as well. We won't be making much use of these in the beginning stages, but it's just to describe what a diode does. Now, as I said, these cause a voltage drop of 0.6 volts. There is another type of diode which is similar to this, called a Schottky diode, S-H-O-T-K-Y. The only difference between that and the standard silicon rectifier diode is it has a smaller voltage across it. So you can use it in really small voltage circuits. Rather than it needing 0.6 to activate, it might need 0.3. There's another kind of diode. Again, we won't be using it in any of our experiments, but you might have heard of it. It's called a Zener Diode. It has totally different characteristics. It's usually used in DC voltage supplies, where it allows current to flow one way, but it has a reverse bias of a certain voltage. And say it was 12 volts on a Zener diode. Once it gets to 12 volts, it allows electricity to flow the other way, but clamps the circuit to a certain voltage. Don't worry yourself about that. We won't be using Zeners, but we might be using standard 1N4007 diodes in later circuits. So that's a diode. So why am I talking about diodes? Well, LEDs, the things we're going to light the kit up with, are diodes. The difference with these is they can't perform a function exactly the same as a diode does. What happens is, there's a nice big red one, is that the power can go up and through this, and in the process it lights the diode up. So that's why it's a light emitting diode. As the power goes through, it lights up. The problem with these is the reverse bias, how much voltage it can block in the opposite way. Again, I hope I'm not boring you all. Most LEDs can only take a reverse bias of 5 volts. So if you're running these on 9 volts, right, and you connect them up the wrong way, and you put 9 volts down the wrong way, current will flow and can damage the LED itself. So don't use these as a diode, as a blocking device to stop power going the other way, because it can only stand up to 5 volts. Right, so a couple of types of LEDs that you might generally use. This one is what we call a through-hole LED. It is designed to go through the holes on a printed circuit board. Okay? You'll also notice that one leg is longer than the other. The longest leg is called the anode, or the positive, and the negative leg is the cathode. Okay? So when you pick up a diode, it's quite easy to see that the longest leg is a positive, where you need to put, say, your red wire, and the shorter leg is the negative, where you need to put your black wire. You will also find on most, I'm just trying to see if any of these actually have it. Actually, the yellow one does. On quite a lot of diodes, you may find there's a small cutout on one side. Okay, and you'll see this when you get the wee electronics kits. The cutout is always towards the cathode or the negative side. So that's another way of identifying it. If you cut both these legs off, that wee slot on the side tells you that's the negative side of the diode. Right, so yeah, power goes through them, they light up, that's great. So what can we get? Right, so let's have a little look. That's just the two standard rectification diodes there. Right, we've got a little range of there. A little range of LEDs here. This is what we call a 1.8mm. This is the smallest through hole that you can get. And it has a tiny little bulb on the end of 1.8mm. The surrounding part of it is bigger than that, but the bit that goes through the hole is 1.8mm in diameter. So that's kind of the smallest. Then we go into 3mm. Okay. Then we go into 5mm. Then you've got 8mm. And then you've got 10mm. A lot of these can be quite big for what we use. They generally come in standard colours of like yellow, red, green, blue, sometimes orange, white. And some of them can have clear domes on them, or as I explained before, they can be cloudy, what we call diffused. You can also get different shapes of diodes, LEDs. This one is an orange one. Again, it's a 3mm one, but it's a different shape to that 3mm one, and it just spreads the light differently. And these ones are all kind of the same, but they're designed just to do end glow. So there are a variety of different shapes and sizes of LEDs in the through-hole variety that you can pick to suit your needs. But you might find that they're too big for model kits. Right, next one we're going to go on to is what we call RGB, or red, green and brown, red, green and blue LEDs. You can get them with 2 legs. The ones with 2 legs tend to cycle. They'll go red, green, blue, back to red, back to green, back to blue. Or you can get ones with 4 legs on, like this one. Now, this one is a common cathode. The one with the black mark on it is a negative common cathode, and all the rest are positives. One's for the red, one's for the green, one's for the blue. Each one requires a different resistor, and you can get ones that are common anode. And again, there's a separate negative for the red, the green, and the blue. This is more if you're wanting precise lighting. but only want to fit one LED. But it's just to give you an idea of what you can get in the through-hole stuff. Now, the other thing, yeah, I'm just trying to remember now. Right, I explained that a lot of different colours of LEDs have different, you'll see it referred to as a forward voltage, or what voltage they work at. And it'll be a range from, typically red and yellows are lower. They're around about 1.8 to 2 volts on the reds and the yellows. And the greens, the blues, and the whites typically work on 3 to 3.4 volts. So that's what they call their forward voltage. They may light before that actual voltage comes, but that's their voltage rating. They also take current. Every single one of these LEDs is rated at 20 milliamps, but that's their maximum. So obviously, if you run them on maximum brightness, they're going to burn out quicker and stuff like that. And that's where we use resistors to take down the amount of current going through them and make them last longer, and also to adjust their brightness. And that will be covered in the next section. Hopefully you're still with me. Right, so you're looking at all these through-hole LEDs and you're going, well, they're massive. I can't get them into a car. You know, what like a car, a 124 scale car, or a 112 scale motorbike. Yeah, okay. So we're going to go on to something called SMDs, or surface mount diodes. Now, this is a little test soldering board, but it gives you the sizes of the SMDs we're talking about. So 0402 is the smallest, 0603 is the next biggest, 0805 is the next biggest, 1206 is next biggest, and 1812 is bigger still. So what do these look like? Okay, right, now where did I put, here we go. I have a little piece of paper here, prepared before. Hopefully these show up, because I'm going to use my multimeter, my standard multimeter. This has a diode checking function on it, and you will see the symbol for diode here. What this does is it puts a small voltage through, and allows you to see which way around the diode is. I'll show this briefly on one of the rectifier diodes. So I'm just going to pull my camera back slightly. Hopefully you can see that. And I have my two, untangle them a bit. I should have been a little bit better prepared. Hopefully I'm not bamboozling you, but I'm just trying to show you the range of LEDs that are available and what diodes and stuff are. So I'm just, right, so I've got a positive and a negative probe here. So here is my IN 4001 diode. Now, the bit with the band on, I'm expecting to be negative, okay? And the one on the other side will be positive. So let me just put my meter on there. And can you see there is a voltage flowing through that? So that shows that that's the right way round, the positive to the negative. If you put it the other way, now 1 means open circuit. No current flows. Okay? No electricity can go through that diode. I put it back the right way with the positive and the negative, and you can see there's voltage running through that diode. So that's how you can tell what way round they are, as well as a little stripe on them. And again, I'll show you the IN4001. If I put it the right way round, you should get current flowing, which we do. And if I put it the wrong way round, oh, excuse me, we get nothing flowing. So that's what a diode does. It allows electricity to go one way and not the other. So here's a red one. Right, so I've got a long pin on the left and the short pin on the right. So if I do it the wrong way round, this diode will not light up, and I get no reading on my multimeter. If I put it the other way round, we should get this to glow dimly, which it has done. We won't get a reading on the multimeter, but it will glow dimly. And it's a way of checking to see if your diodes are working. Right? So the reason I showed you that is we're going to go into some really small stuff. Now, I don't know how well this is going to show up camera. So bear with me a second. I did have my wee surface mount stuff is tricky to solder. Right, so I'm just going to pull. I've also got I've got a wee thing that I made up myself. Things Crivens and help my bob. That I made up for testing diodes or LEDs, so I can check that they're working in various stages. So it's just a 9-volt battery and a wee circuit that I made up. It's just my own wee diode checker, and it's got a couple of crock clips on the end. Right, I'll put that to the side just now and see if I can zoom in on these for you. Okay, right, trying not to get a shadow on this is quite good. Right, so the smallest LED you can get, let's see if I can pull this into shot without blurring everything out again. Excuse me. Right, 0402. This one. Now, when they put them on a circuit board, this is the tiny little pads that this thing has to go across. Right? So you have to solder wires onto these. A lot of people buy them in pre-wired. I do suggest when you're going as small as a 0402, it is worth buying them in pre-wired. Once you get above that, you can actually solder them yourself. So 0402 is the smallest, and that's this little. Let's see if I can get it focused so you guys can see. It's actually what I'm using for the landing lights on that Russian plane I'm building. So let's see, I'll put it in over a screen and hopefully we can get some focus on this. Can we? It's just too small, but you can see it's absolutely tiny. But tiny does not mean it doesn't put out a lot of light. So I'm just going to connect this up. Sorry, I'll pull the camera back a bit again. I'm just going to connect this up to my diode checker. So we'll put the plus on the plus, like so. And the minus on the minus, like so. Have I got it connected? I have. Right. So this tiny little LED, right? Look at the amount of light it gives you. So this is if you've got a really small space to put something into. The 0402 is the smallest surface mount LED you can get, and it gives out a brilliant amount of light. Obviously you can adjust this with resistors, but for something so small. So there you go, that's a 0402. Right, now for the other ones, because I haven't pre-soldered them, I will have to show you with my multimeter. So we're going to go in quite close again and show you a little something about surface mount LEDs that you might not know of. Now, let's see, can I get this central? And down. It's quite hard to get this lit up and show you as well. Let's see, let's get the... Right, where are my tweezies? I'm getting a little bit of flicker here, so hopefully I'll move this back a bit. Right, so this is the back of one of the larger ones, a 1206. And what you will notice on the back of them is in green, you will either have a triangle like that, or a line with a little line coming out, or if you flip them over, a green dot on the front. Now, if you get the triangle type, the large end of the triangle is a positive, and the small end of the triangle or the point is a negative. If you get the one that's like a T shape, the negative is the little sticky out bit, and the positive is the larger bar, and the green dot on the front is always a negative. Now, there are larger chips, these 3528s, where they actually come a bit like an IC. They're square, but there's one corner cut, channeled away. The corner that's channeled away is always a minus, and the other bit is a plus. So let's show you some of these other sizes. Now, that 0402 was tiny. 0603 is the next one. 0805 is the next one up from that. And then we have 1206. Okay, so let's look at the 0603. Again, I'm going to use my multimeter to hopefully, this is quite hard, I haven't really done it before. Now I need to flip this one over, so I've pinged quite a few of these away already. I want to try and get it onto the right side, the light emitting side. Right, you can see that's got a red colour. So that, obviously this isn't full voltage because it's just my multimeter, so it's just showing that LED is working. That's 0603, and that's how small that is. It can go brighter than that, but again, my multimeter only shows, only puts a little bit of voltage down it. Right, let's try the 0805 without losing it. Right, so there's a little green one. Slightly bigger in size. These are not bad to hand solder. 0603s are a bit of pain. 0805s are not bad. Can I get it to light up again? Okay, the easiest ones to solder are these 1206s. That's the wrong way around. Let's just put it the right way around. Oh, all over the place. There we go. This is like a warm white. Oh, other way. Is it that way? Oh, no, other way. Right, there's a tiny little green dot on the right hand side of that, up in the top corner. I don't know if it's coming out in video. But there we go. Obviously that's not its maximum brightness, 1208s. And then we go on to the 3528s. This is a blue one. It's much bigger. Let's see if I can get this one working. It's being a little devil. Right, give me a second. It will comply. I just need to manipulate it. Right, so this is a blue one. You can maybe see it's quite hard doing this. Right, this is just the two solder pads on the back. It's quite hard doing this live, so to speak. That's probably the wrong way. But it does give out a blue. These are quite good. I've used these in my Peterbilt. They're a decent size to work with. They're about 3mm by 2mm by 1mm. Right, I'm just going to scroll back out again. So that's the different sizes of LEDs. Hopefully that's been useful. Practical applications. Right, what have I got to hand? Right. On my Peterbilt truck, I need to pull out my little, I'll get rid of my multimeter off the bench for now. And I'm going to use my little diode checker device again. Let's just come back up. There we go. Please stay steady. Right. So on my Peterbilt truck that I'm doing, where are we? The rear lights on it. Okay, indicators and brake lights on this, and I've soldered them in, and I've run cables up, and these are the end of the cables. So let's just see if I can remember which ones were which. Right, so there's a black. Okay, let's clip onto that one. See if I can get it right. And there's a red. So this is either stop light or indicator. One or two. Can I get it working? Nope, because it isn't that red one, it's the orange one. And the black fell off. Right, wait now. It's quite tricky when you're working with such small wires, but I'm just trying to show you what I've... Right, so let's try black and red. I'm thinking that was the code. It's been a while since I've touched this Peterbilt. I think that was the code of colours I used for... Yeah, it was. Now can I get this so that you can see? Probably not, so I need to get this way. Bear with me, guys. I'm just doing this ad hoc. I don't script any of this stuff. I'm just trying to show you actual uses of the wires in an actual kit. Obviously, when I do my Porsche build, I'll show you what's what, but can I get this to clip on? It all seems so good in my head. Right, can you see that? That's a brake light. Right, I used a 1206 for that because it was nice and small. So that's just kind of... they're all 1206s, indicators in the rear brake lights. And where I did my headlights and everything like that, they're the bigger 3528s. Right, so I'm going to introduce you to a handy little tool that I bought myself. We talk about when you buy stuff, LEDs and that, they come with a milliamps and voltage rating. So these ones are blue. These are the 3528s. That's the one that I showed you lighting up there, the big one. They tell you they're 20 milliamps and 3 to 3.2 volts. That's great. But sometimes when you're doing the through-hole stuff, you don't know what it is. So I've got a handy little tool. It was only about a tenner on Amazon. You can use it for testing quite a few things. So I'm just going to put an LED in there. And I don't know what the forward voltage of this is or anything like that. And I just hit the test button. So it comes up and it tells me, it does a wee bit of flashing and stuff like that. Come on. It tells me the forward voltage of this is 2.19 volts. They do have a certain capacitance. And it tells me which way around it is, pin 1 and 2, which is the positive and which is the negative. Yeah, so if you've got a wee tool like this, you can actually check and see what the polarity of your LEDs are and stuff like that. You can also check your diodes. Let's see if I can get this working. So this is an IN4001, 4007. 1N4007, and that's telling me it's a diode, what the forward voltage required is and what way around it is. So I find this a handy little tool. It can also be used with resistors. I'll show you it when I do the resistors as well. Don't need it, but if you're into salvaging stuff off old circuit boards, it's a handy little tool. You can check quite a few things with it. Some things confuse it. And it comes with a little ZIF or zero insertion force socket. What I do find, if you do get one of these, sand away the middle pin to make it sit better. But yeah, it's just another little tool. But generally speaking, when I buy LEDs, I know what the voltage and everything of them is. And if I don't, I plug them into my little tool. Can't do that with the surface mount ones, but they usually come. This is where it might surprise some of you guys. There's a bag of 100 blue 3528 LEDs. £3 for China for 100. Yeah. These are 0603 SMDs orange. £3 for China. Now, a lot of people will say, just buy white ones and dip them in the Tamiya Clear or whatever. Yeah, that works. But if any of you guys have ever had to replace an orange indicator bulb because the oranges started flaking off, it doesn't quite give you the same intensity of colour as a dedicated orange or a blue or a green LED will. But if you don't want to buy all the different colours, even though it's like £3 for 100, you can just buy white ones. White LEDs give out the most brightness, the most light out of them all. So if you want something that's bright, then yeah, don't buy orange and green and red and all the rest of it. You can just buy white and dip them into Tamiya clear. What I mean with the Tamiya clear coats is you get the X26 and X27 clear orange and clear red. It's perfectly fine to dip a white LED into that, let it set. It will give you an orange or a red, but it won't give you the same intensity of orange or red as you will to a dedicated LED. Right, I think I've waffled quite enough. I'm quite good at waffling, actually. Now, I've been giving this some thought on where to progress in the series, so hopefully this gives you an idea of what LEDs are available in both through-hole and the surface mounts and what sort of sizes they are, and you know what you've got to work with. So if you're trying to put something into a gap and you know you've got hardly any space, but you want an intense LED, you might want to go for the tiny wee 0402s. But they're all different numbers. Some are metric, some are imperial, but 0402 is smallest. Next up 0603. Next up 0805, and then 1206, which I use a lot, and 3528, which I use a lot. But the other ones will go into smaller spaces. On my Space Shuttle and my X-Wing, I just used 3mm LEDs. Now, these are just standard on-off LEDs. That one's an RGB. As I say, you can get them in 2-pin. You can also get LEDs with flicker on them. I do have them as well. Red flicker, blue flicker, and all the rest of it. The only thing to watch out with those is how you wire them in the circuit, and I'll explain that when we go into resistors and stuff like that. So I've been thinking long and hard about how to progress with the rest of this series. The next important thing after LEDs and making your LED choice is resistors. So the next one will involve some maths. I talked about voltage drop, where everything in the circuit needs to sort of add up to the battery voltage. That's called Kirchhoff's law. I didn't want to overcomplicate it, but that's basically what Kirchhoff's law is. We will be going on to resistors, ohms, Ohm's law, and how to work out wattage and stuff. That's going to be the next one. Okay, so this will enable you to, after you've chose which LED you want, you know what voltage it runs at and what millivolts it runs at, how to pick the correct resistor, how to identify them, what different resistors you can get. So you can do the most basic of circuits. You want to light a headlight up, so you want your LED and a resistor to suit it. So this is LEDs. Next one in the series will be resistors. And then I was thinking of what would I do next? Well, if you don't want to go into complex stuff where we're going on to flashing stuff, all you want to do is put an LED bulb in with a resistor and make it light up. I think the one after resistors will be soldering. Basic soldering, how to solder, about flux, different types of solder, temperatures and things like that. And then after that, I'm going to go on to capacitors and transistors and simple flashing circuits and trying things out on breadboards. I think that's a good plan. As I say, I'm winging it. I've had really good feedback so far. If I haven't explained anything fully in this, please do tell me and let me know so I can maybe just highlight any issues that you didn't quite understand in the next video. As always, do feel free to support me on my Patreon. I'll just put it up there. You don't have to. Patreons just get it up a few days early and it helps support my channel, but there's no obligation. But as always, hope this has been useful. And until the next one in my electrickery series, which will be resistors, happy modelling, guys, and see you later. Bye.